Hi, in this lecture we are going to implement the stack abstract data type from scratch. It's very important, as we have discussed in a theoretical section, that we are able to implement stacks with the help of arrays and with the help of linked lists. So this is what we have been discussing. As you can see, that a stack can be easily implemented either with arrays or linked lists. In this case, we are going to use the array representation, and basically what's very important, that the main feature for stacks is the LIFO structure principle, that the last item we insert is going to be the first item we take out. Okay, so we just have to create a class, for example stack, okay, and I'm just going to have a init. It's going to be the constructor with the self as usual. And we just have to create a stack named one-dimensional array. Okay, we can define the isEmpty method. For example, it's going to return whether that given stack is empty or not. So it's going to return the Boolean value, true or false. We just have to check whether that given stack is equals to an empty array or not. Okay, so if it is equals to an empty array, it returns true, which means that the given stack is empty. Otherwise, it returns false, which means that the stack is not empty. Okay, then we will have the two most important methods concerning stacks, the push. Okay, sorry for the typo, of course it's push. With the push, we keep pushing, so inserting items into this one-dimensional array. So we just have to say that the self.stack, we keep appending the given item. Okay, we have to define the item or the data we would like to insert, and we just have to append it, that given data, to the stack. This is how we append a given item to a one-dimensional array in Python. Then we have the pop method. So def pop with the self. Because stack has a LIFO structure, the last item we insert is going to be the first item we take out. So we keep pushing items onto the stack. So we push the 12, we push the 56, we push 88, and if we call the pop method, it's going to return the last item we have inserted, as you can see. If we call the pop again, we are going to pop 56, and so on. Okay, so the pop is going to get the data, so self.stack. And if we call the -1 index, it's going to return the last item. So if we have the -1, it's going to be the last item in the array. The -2 represents the item before the last one in the array, and so on. So this -1 is the index of the last item. Then we have to get rid of the reference. So self.stack -1. And then we return that given data. So it's very important that we get the last item and then we get rid of the reference. Okay, with the help of this del keyword. Okay, and what's very important, that we have this peek method as far as stacks are concerned, which is going to return the last item we have inserted without removing it from the stack. So as you can see, the peek is going to return the value 88, but it's not going to get rid of this item. So the structure of the stack remains the same. Okay, so that's the main difference, that the pop is going to get rid of the last items. The peek is just going to return the value of the last item without removing it from the stack abstract data type. So here we just have to return with the self.stack and -1. And we can define the size method, for example, size stack. It's going to return the len of the self.stack. So it's going to return how many items does this stack contain. So let's test it. I would like to first of all instantiate the stack. Then I would like to push, for example, 1. I'm going to copy and paste it. I would like to push 2, push 3. Okay, then I would like to print out the size of the stack. So size stack, okay. Then I would like to print out that popped, and I would like to call the pop method. Okay, I would like to call the pop method again. Then I would like to print out the size of the stack. Okay, and before printing out the size again, I would like to call the stack.peak method. And maybe I'm going to print it again. So I would like to peak. Maybe I'm going to print that we call the peak method just to make sure that it's going to be straightforward at what's happening in the background. Okay. And let's run the python stack.py. Okay. First, we push 1, we push 2, we push 3. So the size of the stack is going to be 3. Then we keep popping the items. Because stack abstract data type has a LIFO structure, the last item we have inserted will be the first one we take out. So that's why 3 is going to be popped out, 2 is going to be popped out, and that's why the size is going to be 1. Because we had 3 items, but we have popped out 2 of them. Okay, then we peek the item, which is going to be the value 1. But we are not going to remove it, and that's why the size is going to be unchanged. So this is how we implement the stack abstract data type with the help of one-dimensional arrays. Basically, we have 3 important methods: push, pop, and peek. Push is going to insert items onto the stack. Pop is going to remove the last item we have inserted. And the peek is going to return the value of the last item we have inserted without removing it. So it's not going to change the structure of the stack. So that's all about the stack abstract data type. Thanks for watching.